Hello and welcome to the Chandara Academy. Sumsokon Mokan Chandara Academy. In today's video we are going to calculate the following limits. First we will have the limit when x tends to plus the infinity to a composition of function ln of this function. And then we will have a very easy function to get the limit, which is a function mixing some exponential and some polynomial. We will use what's called compared growth. Perfect. Let's start with the first one. When x tends to plus the infinity. Okay, so let's say for large x. Okay, so I've got an x, but I know it's large. We are not going to the infinity, I know it's large. X minus 1 over x plus 1 is also equal. In this kind of case, when we want to go to the infinity, we factorize by the strongest element, x times 1 minus 1 over x, 1 plus 1 over x. Now I can simplify both, and having that, I know that the limit, let's call this g of x, or u of x, I know that the limit of u of x when x tends to plus the infinity will be equal to 1 minus this thing which tends to 0 over 1 plus 0. So this is equal to 1. To 1 over 1, which is equal to 1. But now we know that the logarithm ln is continuous. This is very important. Continuous around x is equal to 1. This is continuous around x is equal to 1. We can do the graph again if you do not remember it. This is y, this is x. Around 1, we've got our logarithm that goes to 0, okay, for all logarithm, especially for ln of x. And knowing that our function is continuous around 1, the limit of ln of u of x when x tends to 0 is equal to the limit of ln of u of x when x tends to 1, which is equal to ln of 1, because this is continuous, and ln of 1 is equal to 0, and we can conclude by saying that a is equal to 0. Now let's do the second one, which is a lot easier. When we are in plus infinity, there are some terms that will be more powerful than others. So let's do a little graph to imagine the thing. This is powerful, and this is weak. Okay, the weakest ones are always the logarithms, ln, log in base a, we don't really care. The logarithm, then we have the x to some power. So first the square roots, of course, the roots, then the regular x. Okay, the exponents growing, we get more and more powerful. Then we will have maybe x squared, and basically x to the n. Okay, every x to the n in order, in growing order. Then what will we have? We will have exponential functions. Of course, with a greater than 1, we will have a to the n. Then we will have a plus, we will have every a to the n. Of course, b to the n if b is greater than a and greater than 1. And this thing in plus infinity would be a lot more powerful than this thing. It would be a lot more powerful than this thing. Okay? They are not equal. They are very powerful, and the limit will be determined by the strongest term. And at the end, we have the factorial, and at the end of the n, we have n to the n power. Perfect. Here, we will use the comparison between powers of x here. of course 7, we don't really care about this one, and the exponential which is here. Let's do it. Let's call this one g of x. G of x is equal to x to the third plus 7 minus 2 exponential of x. Let's factorize by the strongest term. Of course, for x large, this is equal to exponential of x times what? Times x to the third over exponential of x plus 7 over exponential of x minus 2. And what do we know? We know that, of course, this will tend to plus the infinity. This will tend to 0 when x tends to plus the infinity because of the compared, let's say, compared growth. Okay, CG compared growth. This one will easily tend to 7 over infinity, which is equal to 0 when x tends to plus infinity, and here the minus 2 stays, of course. And we conclude that the limit of g of x when x tends to plus the infinity is equal to plus the infinity times what? Times minus 2, which is equal to minus the infinity. And so the solution to b is equal to minus the infinity. And we have solved our exercise. I hope you enjoyed the video. See you soon. Bye.